still there?
Yeah, I'm here.
Okay, so class, John is our tutor, embedded tutor. So she is a tutor exclusively for this class. So John is going to introduce her to our class. Okay. All right, John, you can go now.
Okay, hello everyone. My name is Zhang Li, and then I'm an embedded tutor for this class. I'll usually be staying at your Zoom at MathLab Tuesday to Friday from 4 to 6 p.m. If you have any questions, feel free to drop by our Zoom session or email me. You can check my email address in class announcement. Thank you.
Okay, so do you have any specific office hour, John?
Yeah, my office hour is Tuesday to Friday from 4 to 6 p.m. at MathLab Tutoring Zoom.
Okay, MathLab, right. Okay, and I think I did write your email under our class announcement, so I think they have the email. They can contact you directly, right?
Yeah.
Okay. All right, very good. Thanks, John.
Okay.
Anybody has any questions to our tutor? Does anybody have any questions to our tutor? No?
To be in class amount and the class announcements, correct?
Yeah, my email address is in the class announcement. You can check my email address there.
Again, I'll try to make another announcement mentioning your the times from Tuesday through Friday, 4 to 6 p.m. in the math lab. And everybody has the ID, the Zoom ID for the math lab. Okay, that's good. Thank you.
No problem.
Okay, thank you. Okay, so this is today's agenda, midterm zero review. Again, we had the test last Friday, so I'm going to make some comments about that, and the answers are posted under files. It is usually posted at the very top, and then I'm planning to go through section 1.4, 1.5. 1.5 kind of officially begins our course Calculus 1, and so we will start the concept of limits. And then section 1.1 we already went over. So what we have is I did not go through section 1.2 and 1.3. But 1.2 and 1.3 are kind of pre-calculus and algebra. So let me write pre-calculus, and algebra mostly. Okay. So and graphing too. But anyway, mostly pre-calculus algebra. And so I'm planning to give you midterm 1 this Wednesday, which is January 12th. So this is a 6-week class, so we are fast-paced. So instead of spending too much time on pre-calculus, I think I'll spend enough time here. So whenever you have some questions, class, I will go over, or you can ask me, or you can ask the tutor. You could go to the math lab. Okay, anyway, whatever help you can get it. And so that is my game plan. Okay, so now what I'm going to do is I'm going to open up the midterm zero answer key file. Okay, so let me do that. So let me save this and then clear, and then where am I hitting? Oh yeah, files. I would like to go through the files. So files here, okay, files. There we go. Oops, where's my files? Okay, there we go. So share screen and let me now share this. So this is the file you will see. So again, the name of this file is called star, and then space math zero midterm zero answers. So all the answers to the question, the test, the midterms, and the quizzes. I don't post the answer key to every single quiz, but for tests. But most quizzes and all the tests, I usually do put the answer key, and they will be found at the very top. So I'm going to start the file name with the asterisk so that they will show up at the very top. So this file is again Math 7 midterm zero answers. You can see it. So if you open up, this is a file, and this is what it is. So we had, I think we had 7 problems. Okay, so these are the answer keys. Now, most of you got it right on number 1 and number 2A, 2B, and 3, so I'm not going to spend too much time, okay? So here are most of you, so number 1, 2, and 3 were relatively easy compared to the other problems. So the interesting problems really begin on question number 4. So let me, okay, again, number 1, 2, 3, you can just look at it. And again, most of you got it right, so there's nothing much to look here. And so let me now make some comments about number 4. Okay, so number 4. Number 4, we have to find a fourth degree polynomial which satisfies all of these conditions right here. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 conditions. But all we have to do is find a fourth degree polynomial, And now, in order to do this problem, there are many ways of doing it. And so the method I'm showing you, this is actually the best way, or something of this sort. Now, all of you some of you might have solutions which are a little bit different, and that's okay. Again, in this class, as long as you present a mathematically reasonable solution, I will accept it. Now, let me just remind you, in this class, you have to show me your work. You have to show me your work. You have to derive the answer. Now, some of you, what you did is this. Some of you write the solution. You write that this is the solution right here, and this is the only solution, by the way. This is the solution. Oh, sorry, that's not the solution. So I marked the wrong thing. I boxed the wrong thing here. So let me undo this. The solution is this guy right here. Now, some of you, what you did was you somehow wrote this answer, or you guessed the right answer, or you make an attempt, and then you give me this answer. And then you explain to me that this function right here, it satisfies all of these conditions. Now, if you write the answer first, and then verify all of these conditions here, that is not an acceptable solution. That's what I call verifying. So the question is this. You must derive the solution. Again, deriving the solution, not the same as verifying the solution. Okay, is that clear? There's a big difference here. Verifying the solution is not the same as deriving the solutions. So in this case, from scratch, you have to figure out the fourth degree polynomial. You have to find that out from nothing. Not from nothing, but from the given condition. So you cannot just write the answer and then show that that is the true answer. Well, that verifies that that's the solution, but in this class, you need to derive the solution. Just want to remind you. Some of you tell me, well, isn't that the solution? Yeah, that is the solution. So many of you somehow found this answer. Now, of course, there are many ways to find the solution, but yeah, you find the solution through some attempt or by guessing or something. But again, as the problem gets more and more difficult, let me just remind you, guessing the answer will become more and more difficult. So that method you apply does not work. Eventually, at some point, it is going to break down. So in this case, you are required to derive the solution. Again, not write a solution and then show that that is the solution. That is not good enough here, all right? So there's a big difference. Okay, so here, this is how we derive the solution. Okay, it is the fourth degree. And so the starting point is you have to do it this way. Okay, since if you look at the conditions, there are three special conditions here. The conditions are, one second. Oh, there we go. So we have f of negative 3 equals 0, and we have f of 0 equals 0, and then we have f of 2 equals 0. And I think, yeah, many of you did notice that. So we have these three special conditions. We have already 3 zeros. So what we have is, we know that we have x, and then times x plus 3, times x minus 2. And then the other factor should be g of x. And we know that g of x is a linear function. So you can write it like this: A times AX and then plus B. Or what you can say is you can say or M is or G of X is equal to M times X minus N. If you write something of this sort, that's okay too. So either G of X is AX plus B, or you can actually substitute that G of X in there, or substitute G of X equals M times X minus N, or A times X minus B, or something. You are free to use any letter you want besides X, or okay, so something of that sort. And then you plug in, and then because the G of X is linear, we only need two conditions. So in this case, what I did was I just used the two conditions which we see right here, which is f of -2 and f of -1. And then this condition and this condition right here, we don't need it. Now these two conditions, of course, at the end, when we verify, it will be true, of course. When you verify, those points you have to still check. But anyway, you get this. So when you actually and then you plug in those two values, x equals -2 and -1, and then plug in, then you get this G of -2 equals 2. And then when you actually plug this into G of X equals AX plus B, you get this. And then solve the system of equations, and you get that, and then there you go, that's the answer right there. Okay, so this is the best way. Of course, some of you did not do it the best way. So let me just remind you, in this class, when you study, don't stop your study when you find a solution. All right? Always check to see if there are other ways. Okay? Also, always check your solutions. So traditionally, for any math class, for any math you study, I think the students are used to stopping their study when you get the answer. But this is now calculus 1. You have to be a little bit better than that. So in this class, whenever you study, whatever you study, doesn't matter what topic you study, there are more things I want you to do. So you study, and then you get the answer. So after you get the answer, what else is there to study? What you study is this. When after you get the answer, and hopefully that is right, well, it may be wrong too. So what do you do after that? Well, you don't just take chance here. So what I want you to do is look for other ways. Of course, on the test, I will never ask you for two ways. So on the test, you just need to give me one way. But in math, if you want to learn the best way to solve any problem, you cannot just learn the best way. You have to learn many ways, and then you get to learn the best way. All right? So when you study, learn also. How many ways do you want to know? Many ways. No, well, not all the ways, but many good ways. Many good ways. And another thing is you should always check your answer. On this test too, some of you did it, then you didn't check, and then it's wrong. Again, in this class, let me tell you, in this class, the penalties are unfairly high. In this class, penalties on mistakes are unfairly high. Is that clear? I do not take 1 point or 2 points. That is not my style. If there's a 10-point problem, I see a tiny mistake, 5 points off, 8 points off. And sometimes if you make a very big mistake at the very beginning, by the way, I will assess when you make mistakes, the two things are considered for determining for for what? For penalties, I consider two things. Penalties. What kind of mistake? What kind of mistake? That's one thing I consider. But the other kind of question I'm going to ask is this: when are you making the mistake? When is your mistake? When are you making the mistake? Making the mistake. Mistake. So mistake at the beginning. Mistake at the beginning. At the beginning of your solution. Beginning of your solution. May cost the entire problem. Cost the entire problem. What that means is, if you make a mistake at the very beginning, that is much more costly than the mistake you make, the same mistake at the end. Let's say 1 plus 2 is equal to 5. Let's say you have 1 plus 2, and then you have 5. That same mistake, if you make at the very beginning, could cost you 10 point, 10 point or maybe 8 point penalty. Whereas if you make that same mistake at the very end, I might just deduct 1 point. So if you have to make a mistake when? At the end. So you never want to make a mistake at the very beginning. Again, let me tell you, if you are going to make a mistake, hopefully you will make a mistake at the end. Because if you make a mistake at the top, then you are completely changing the problem. And that's exactly what happened on this test too. Some of you make the same mistake, any kind of mistake, copy mistake, any kind of mistake at the very beginning, and you alter the problem significantly. And most of you, when you change your problem, you change into an easier problem. And so, you know what, there's the whole point is lost. So that is essentially 10 points off. Okay? There's nothing for me to grade. You have made it to a much more trivial problem. That's what usually happens. Although sometimes when students change the problem into a more difficult problem and then they solve that problem, sometimes I will give them most of the credit. Okay? So it depends on when you make the mistake and what kind of mistake you make. Okay? Any questions on these policies here? I'm sure that you have already figured this out. But anyway, in this class, penalties and mistakes are unfairly high. Unfairly high. So don't say, oh, you asked me, you took 8 points off for this tiny mistake? Yeah, that will happen in this class. So you have to check your work. Check your work. Why? Why do you check your work? Is it because it's required? No. You don't check your mistake because it's required. You check your mistake because you make mistakes. Check your solution because you make mistakes. That's the only reason. If you think that you didn't make a mistake, then you don't have to check it then. All right? Okay, so number 4, any questions on number 4? Again, not
I have one
everybody.
question regarding number 4, specifically the systems of equation part. Can you show us the formula where you derive a is equal to negative 1/2 and b is equal to 1?
I see in this case. Okay, I'll show you. That's actually not bad. Okay, here. So this is this, and then it's this right here. And note that we have a plus b. And so the question is, let me call this equation 1. So this one, let me call this equation 1. Equation 1. So let me maybe write this in blue color. Equation 1, and then this second equation, let me call this equation 2. Equation 2. Now, when you look at these two equations here, we have plus b and plus b. So we see a difference here. So a is equal to negative 5. That we can get by taking the difference. How about this? Take the difference. Take the difference. Take the difference. Equation what? Equation 2 minus equation 1 side by side. So now take the difference. Equation 2 minus equation 1 side by side. What that means is, on the left-hand side, okay, let me convert that to change to red. So on the left-hand side, what we have is this minus a plus b is the left-hand side of equation number 2, and then the left-hand side of equation number 1 is minus 2a and then plus b. So So the left-hand side becomes what? The left-hand side becomes this, minus a plus b, and then minus 2a, and then plus b. You get this. And when you simplify all that, you actually get a. So that's why you took equation 1, 2 minus equation 1. You can do equation 1 minus equation 2. If you do that, you just get minus a, that's all. So you can either do equation number 1 minus equation number 2, or equation 2 minus equation number 1. In this case, since we have minus a on the bottom and the minus 2a on top, if you do equation 2 minus equation 1, there will just a straight. And then equation 2 minus equation 1 side by side, that will be 3 over 2 minus 2. So we get this, a 3 over 2 you get this. So this is what I mean by equation number 2 minus equation number 1 side by side. So when you simplify this, what do you get? The left-hand side becomes a, and the right-hand side, that becomes minus a half. So I thought that was simple enough, so I didn't write that middle step there. So you get a equals negative half, and once you plug in a equals negative half into either equation, then you can get b equals 1. So that's how you get it. So you can plug in this a equals negative half into either one, and then b equals 1 either way. So that's what you get. And once you get that, of course, you want to check all the conditions, especially how about checking these conditions right here, which were never applied. But when I didn't check here on our answer key, but when you actually plug in, these conditions will be satisfied as well. Of course, you should be really checking everything, but especially the 2 points which we never used. I think those are the good conditions which we want to check in this case. So if you check it, you can check all the equations and you get it right. So, and most of these equations are very easy, like f negative 2 equals 0. Yeah, it's already built in here. It's not hard to check these guys. So the check can be done very quickly. And then you can check the other guys too. Anyway, any questions here? So is that good enough? Again, those of you who have problems, or those of you who forgot how to solve equations, systems of equations, make sure that you learn them. Systems of equations might show up on every midterm, on every test, every quiz. It shows up everywhere. Systems of equations can be found under intermediate algebra, math 20. I guess in this class, I did not post the notes, but anyway, it's intermediate algebra. So you can just look up anywhere, or go to OpenStax and look for the topic, and then open the book, intermediate algebra, and then you find systems of equations. Usually there's a chapter titled systems of equations. Again, it's usually they devote one chapter, and you can look for it. It's a chapter called systems of equations, and then you can do this. All right. And the method I'm using here is the addition method. You can do substitution method, addition method, and so on. Okay. Any other questions on problem number 4? Oh, excuse me. 1 second. Okay, excuse me. Okay, so problem number 4 is now done. And by the way, the solution I gave you is actually the most general, the most standard, and the fastest solution. Logically, it's very clear. And also, of course, you have to know these facts here. So you have to know a lot of stuff. And so this is the best solutions out there. Many of you wrote f of x equals ax to the 4 and then plus bx cubed plus cx squared plus dx plus e. Those of you who did it that way, that would be probably the longest way possible out there. Okay. So anyway, so you know what? Those of you, even if you got full credit on that problem, please study the solution I present you on the answer key. Again, the answer key I present you here, this is the best solution out there. Now, when it says best, what is the best solution? What is the best solution? Best solution What is a best solution? How do you know what is a best solution? Well, best solution, there's some criteria. The best solution means it is what? It is shortest, and then less risky, meaning less messy. You don't get into too much calculation. Less messy means what? Least calculation. That's what I'm going to this. Least calc. Okay, least calculation. Less messy means least calculation. So let me put this here. Least calculation. Calculation. And third criteria is what I call extendable. What does extendable mean? Can be applied to more complicated problems. So generally, of course, you know what, this is my thoughts, and it's not like this is not like a theorem, but in general, a method, how do you judge whether a method is good or bad? A method by three criteria. One, is it the shortest? Is it taking the least amount of time? Shortest meaning the least amount of time. Least amount of time. Okay, that's what I mean by shortest. Now, second is criteria is very important. It's less risky. What does less risky mean? Less messy. That means least calculation. So when you look at the solution, you know what? When you look at the solution, it's not like f of x equals ax to 4 and the plus bx cubed plus c. You know what? That one has a high chance of making a mistake. So many times when students make a mistake, you know what the mistake is? Not the fact that they made a calculation mistake, but that the method was inefficient. So the inefficient methods, or less risky, and the long methods, they're not good because it's more risky, more time. So many times when students make a mistake, the real mistake is not that they made a calculation mistake. You know what? I make the same kind of mistake like many of you do, maybe a little bit less, because I did more math than you did. But I usually do the problem in the best way possible. Well, not all the time. Sometimes, you know what? Students tell me that there's a more efficient way, and I'm glad. If any of you can tell me that, then that's very good, okay? But you have to look for the better way. So again, like in the bottom, what I said, you found the answer. That's not it. That is not it. When you get the answer, I would say that's about the halfway point. And then, also, you know what? Here, also, you know what? Also consider variations of problems. Also consider reverse problems. So let me also consider reverse problems. Also consider reverse problems. Now, what is it? What do I mean by reverse problem? A reverse problem is what? Given the answer, you have to guess the question. So can you do that? It's like Jeopardy. And this is, this is not my thing. These are very general things you have to consider. So what do I mean by variations? Variations mean you have a problem, and then instead of this problem, something might be a little bit different. So when you see x squared, then you know what? Next time you're not going to see x squared. It might be x cubed. It might be square root of x, or it might be x plus 5, or 2x plus 5. So those are what I call variations. So when you have one problem, the next time the problem shows up again, it might be changed a little bit. Okay, so you have to consider all these kind of things. So general, when you do a problem, you solve a problem, and you get the answer, I would say that that's about halfway point. So you have to learn to analyze. Look for better ways. So the method you have applied, is that the best way? So that is something you have to consider on all problems. Also, always look at the algebra. When it's an algebraic problem, then you also look at the graph. You also look at the geometric aspect of it. Always consider all aspects of the entire problem, all the time. So you have an open mind and try to study. So basically, what I'm saying is, when you study, consider everything and anything goes. Okay. So just have an open mind. Okay. So now we go back to best solution. Three criteria. Is it the shortest? Second, it's the less risky. Okay, less messy, or least, okay, that's least calculated. Third one is extendable. I'll talk about more about this here. Extendable means, can it be applied to more complicated problems? Okay, so many of the methods you apply, it's not extendable. And so it's, it's not efficient, in other words. So anyway, these are the rough criteria. Okay? So, class, if you know only one way, don't tell me that's your favorite way. Okay? You don't know what's your favorite way. If you have only one way, then that means you don't have a favorite way. That's the only way. But in this class, learn every best way possible. All right? That's your job. Your job is to figure out the best way. How do you learn the best way? You learn the best way by learning many ways. And hopefully, you learn many good ways. A few good ways. Ideally, you want to learn at least a few good ways. And look at all kinds of variations here. I only gave you one version because I cannot, I don't want to confuse you. But again, basically this is it. Again, if you have any minor difference, that's okay. Like g of x equals ax plus b. Or you can write g of x equals m times x minus, or you can just not use the function g of x, but plug in there and then let f of x equals, and then just plug in that g of x, m times x minus n. So there are small variations, but roughly this is the solution. Okay, one last chance. Anybody has any questions on number 4? Okay, if you have no questions, then you can always ask me questions later, or you can ask your tutor, or you can ask folks from MathLab. Okay, so that's it. And so now let me scroll through. Let me scroll through now number 5. Yeah, number 5. There you go. F of x equals x cubed plus x squared plus cx in the plus d. And we want this polynomial to be divisible by what? By x minus 3 squared. Now, there are other ways too. Now, many of you, what you did was, you noticed that this x minus 3 squared, because you have a square there, this is not linear, so you expand this. X squared, and then what? Minus 6x, and then plus 9. And then what you did was, you applied the long division, which is okay. So if that's what you did, okay, that's okay. That is actually much, much better than not solving the problem. So you can apply what? Apply long division. Apply long division. Apply long division with this divisor. With divisor, x squared minus 6x plus 9. In other words, you have that f of x, and then divide that by x squared minus 6x plus 9. If that is not a linear expression, linear polynomial. So if you did that, that's okay. I think many of you, I don't know, I think about half of the class, I think that's what you did. Because you probably did not know how to do it in a better way. But now in this case, that's the better way. The method I present you right here is actually by synthetic division. This is the best way. But you cannot divide by x squared minus 6x plus 9 on synthetic division, because, synthetic division you only divide by a linear polynomial, or x or plus minus a number, so x minus 3 in this case. So in this case, what you do is apply long division, divide by x minus 3. So this is what you see. And then when you do that, this is what you get for the remainder. And then when you divide that, and then if you divide x minus 3, then that must be 0. So we want that means this to be 0. And then we have a quotient here. And now, that quotient, we divide by x minus 3 one more time, you get this. And then that will be the remainder. And then we let that be that. And then you get this. Yeah, I would say most of you got this answer, but more of you actually apply the long division, which is not the simplest way, but that's okay. That's fine. Again, in this class, there is no penalty for, in this class, let me just remind you, I never deduct any points because the method is long or the method is inefficient. Although I don't like it. I mean, that's not the best way to do it, but I don't take up points. I only take up points when it's a mistake. Everybody, is that clear? Mistakes only when there's a mistake, not when the method is long or inefficient, even though that happens all the time. But you have to be careful here, because on later tests, on the next test, if I give you this kind of problem again, do you think I will give you a cubic polynomial? No, I won't. I'm not going to give you a cubic polynomial. You know what? I might give you a 7th degree polynomial, 10th degree. What happens if I give you a 10th degree polynomial, and now you want to get into long division? Well, that will be a chaos now. So if you apply this by long division in this case, it will not be extendable, basically. So the solution must be extendable. That means you have to prepare for the worst. So if you did apply long division here, you're not preparing for the worst. You got lucky this time because it's a qubit. Again, on the next test, you might get a 22nd degree polynomial. You know what? I might give you that. Don't be scared, okay? And then if your method is inefficient, your method is going to break down. Okay? So you have to be very, very careful. I'm not just always going to give you a qubit. On this midterm 0, I gave you a qubit, but you're not going to see a qubit all the time. You might get a 7th degree, 10th degree, 12th degree, you name it. It is going to show up eventually. So you have to prepare for the worst. Okay, so any questions on number 5? Any questions on number 5? No?
Just one quick question.
Yes.
For in the first set of division, when you have 3, 12, and then 3c plus 36,
Yeah.
the way you got that, and pardon me if I made a mistake here.
This is a synthetic division. When this basically we have. So let me tell you. How about this? Let me mark this in black. So the ones in black, that's the original problem. The original problem, when the setup will be to write these guys here, and then you write this, and then you write this right here. And so so what I wrote down right here, this is the original problem setup. So when you do this x cubed plus x squared plus cx plus c, and then we want to divide this by x minus 3, so we are dividing this by x minus 3, not by x minus 3 squared, then this is the setup. You only have the circle numbers, and then you have this bar. So that's the setup. So we are ready to divide x squared, x cubed plus x squared plus cx plus c, and then divide by x minus 3. So when you divide that now, how do you get the numbers here? You bring down the 1, you bring down the 1. 1 right here. And then, once you get the 1 there, what you do? 3 times 1 is now 3. So what you get is this, basically. So once you get the 1 there, so what do you do next? You do 3 times 1. And that will be 3. And then add those two numbers. Add those two numbers right there. What do you get? You get 4. And then after that, you get 3 times 4. Multiply those two, and then you get 12. And then add those two numbers, you get c plus 12. Now we are treating the c like a number, so don't do any weird things. This is c. Treat the c like a number. So when you add, we get c plus 12. And now, what is 3 times c plus 12? That will be 3c plus 36. And then now what? We add, and then we get this. And then that will be the remainder of the first division. But since we want this polynomial divided by x minus 3 squared, it is divided by x minus 3. So that must be the remainder, and that must be 0. So this is what we can call this R1. So that is the remainder. That must be 0. And then we take the quotient, and the quotient must be divisible by 3 again. So now we divide that by 3, and so there you go. And that we have now the setup for the synthetic division second time, dividing that quotient by 3. So when you do that, you get that, and then again, now c plus 33, that becomes the remainder, so you can call this by R2. The remainder from the second division. So what that means is, let's say, how about this? Let's say 7 squared is equal to, let's say, 49. Now, how do you know that a number is divisible by 49? Well, to check whether a number is divisible by 49, what you have to do is divide by 7, and the remainder is 0. Divide by 7, the remainder is 0. So let's say if I give you a problem like how about if I give you, let's say, a number like 9898. If I give you a number like 9898, what is this 9898? What is this number divided by 49? Well, to divide this number by 49, what you can do is you can actually divide this number by 7, and then make sure the remainder is 0, and then take the quotient and then divide by 7 again. You can divide by 7 and then divide by 7 again. And then, of course, you must get the remainder 0 in both cases. So that's what you can do. So here, that's what you do. You can divide by x minus 3 twice. And then in each case, the remainder must be 0 because this is divisible by x minus 3 squared. So this method I gave you right here would be the easiest way. So the next test, if I give you a polynomial and then I ask you, find xx, and then I could ask you, you know what, divide this polynomial by x minus 3 cubed. Oh, then what? Then what do you do? Then probably the best way is to, you know what, well, it depends on what exactly the problem is, but if I give a similar problem and you have to find these parameters by dividing by x minus 3 cubed or something, then you know what? Then the method which I did right here is extendable. You are preparing for the more complicated problems which are similar. Similar, more complicated problems are ready. So when you do the long division, what happens if you now take the cube here? Oh, now that will be starting of the disaster. You get this x cubed minus 9x squared. You know what? You get a cubic polynomial divisor. You have to divide by a cubic polynomial, and that is really going to get messy. Okay, so it's not extendable. Not extendable, of course, it's not the shortest method either. So you have to study, and you have to study the other way, always. Look for the best way. After you have done the problem, look for the best way. Okay, here. Any other questions on number 5? No? Okay. Then, I don't know. You know what? Since the answer, I'm not going to take a screenshot of this one. Okay, it's just kind of messy here. So let me just clear this without saving. There's not much to save here. So clear this. And so now, let me scroll this. Number 6. Number 6. So there you go. So number 6. Again, final points P. And then, yeah, this is very similar to the one we have done in class. So many of you got this one right. So I'm not going to spend time here. Okay. Also, here, many of you did not check, but make sure that you check the other cases where the fractions are not going to work. So when you set up this, I use the letter K here. By the way, here when you set up this equation, I let this P, the point P, be K comma K. So K comma K is okay, or C comma C is okay too. But some of you euro P and then euro x comma x. Now, if you use the letter x here, it does work, but you have to be careful. I really recommend you not to create these points and call them x comma x. If you use the letter x here, this x might get confused with existing coordinates here. X-axis, y-axis here. There's a potential that you might get this x might get mixed up with this x. So x comma x, if you know what you're doing, it's okay, but many times this x is going to mess you up. So this one, you are taking risk here. If you're not sure, never call these points x comma x. Use any other letter, like C or K or A. You can call the P in A comma A. That's fine. Small a comma small a. So we have a capital A right here. So don't call that capital A comma capital A. But don't use any existing letter. And some of you guys call this x comma x, and you actually made a mistake, I think. Well, this one, actually number 7, and you made a mistake here. But anyway, be careful here. Do not use these letters which are already used on that problem. And then when you do that, then you get this, and then of course, when you set up this equation here, note that when k equals minus 6, it doesn't make sense. So the slope of AP is k over k plus 4, and when k is equal to negative 4, then AP is a vertical line, and so this theorem does not apply. Okay. So anyway, you have to watch out. So when k equals negative 4 and when k equals 6, you have to do the problem separately. And these two cases, they are actually easier. Because one of these days, I will give you problems where the solution will be introduced from these exceptional cases. Be prepared. Again, be prepared for the worst. The problems are not always going to be that simple. Okay? I'm a math teacher. I will give you anything I want, anything I can. Okay? Whatever I need to do, I will give it to you. All right? So be careful. Don't say that, oh, well, those exceptional cases, they will never be true. No. it will be true. I think I already gave you an example in class, right, where one of the solutions was through these exceptional cases when one of the line is a vertical line, because the square formula m1 times m2 equals -1. That one only applies when the lines are not vertical and not horizontal. Okay, number 7. Number 7, some of you have some difficulty. Undo. Let me clear this. So we have this number 7. Yeah, example 7, number 7. Let the line be y equals mx plus n must pass through the point -1, -3. And so, what is this? Now, this is actually a calculus problem. We will do this kind of problem, in our class, okay? But this problem can actually be done without calculus. So that's what I want you to do. I wanted you to know, to learn the method without calculus. Now, let me tell you this class is calculus. But if you can solve a problem without calculus, that's actually a great method. By the way, I don't know whether this might kind of sound weird, but sometimes I give you a problem, a problem in calculus, and then one of the students actually solves the problem without calculus. Now, if I give you a calculus problem and then you can solve the problem without calculus, that is only using intermediate algebra and geometry, then do I give you full credit? Oh yeah, you know what? If you can do a problem, if I give you a calculus problem and you can solve the problem without calculus, you know what I do? I will give you double points. That's even better. So when you study calculus, if this is for anything, when you learn something, you have to learn how to not use that. So let's say there are a lot of rules in this class. You learn, let's say we are going to learn a rule called product rule. But then the question is, when you learn a rule called product rule, which you're going to learn in chapter 3, then you have to learn if you know a method where you don't use that product rule, then that's even better. So again, when the method is more primitive, that's actually a good solution. It's a very good solution. All right. So here again in number 7, this problem is specially designed so that this can be done without calculus. And also this is very similar to the quiz. A problem on the quiz. So y equals n is a must pass through -1, -3, -1, -3 over 2. And then when you substitute this guy into this line right here, you get this. And then when you plug that n into this, then you get this line right here. So this whole thing right here, this is now the line. And now we want this line to intersect this y equals half x squared exactly at one point. But didn't we do this in class? Didn't we have a problem like this on the quiz? Yes, we did. We actually had a line and a curve like this, a quadratic function, a polynomial and a linear polynomial, and we want the line to intersect at one point. So what is that? Well, then there's the equation right there, and there's the quadratic equation. So this is now a system of equations, and we want to find the intersection, so that's what we get, and then you get the quadratic equation. And now we want this quadratic equation to have one distinct solution, that is one double root. We want one double root. So discriminant must be 0, and so when you figure out the discriminant 0, and you get this, and then you get the two lines right here. And then the best way to check this, what is the best way to check this problem? The best way to check this problem is what? The best way to check? What would be the best way to check whether these lines are correct? The best way to check, what is it?
Plug it in.
Check by what?
Plugging in the original values that you work with.
Why you can do that? But note that this problem is an algebraic problem, and you can see when you plug that in, and then you can verify that as a double root. Yeah, that is checking by algebra. But how about checking by graphing? Why not? So graphing is actually the best way to check, because graphing method is now completely different now. Besides, you cannot do this problem by graphing. You can, but you can actually check by graphing. Of course, yes, you can plug in this line here, and then when you try to look for the intersection, you will get a double root. Yeah, you can check it that way too. But sometimes when you check the answer, it is always best if you check by a completely different way, especially graphing. And so sometimes when there's a graphing problem, then you check by algebra. When you have an algebra problem, you check by graphing. That's actually the one of the best ways to check. Now here, yes, you can do that. Again, substitute x equals x minus a half, and then plug that into the equation. Y equals half x squared, and then now you can see that it will be you have exactly one root. You get double roots. Yeah, you can do that. So solve it, and then you can find that there is a one intersection. Yeah, you can check it that way too. Anyway, the various ways of checking that I do recommend you to watch. In any case, always, what is it? Always check. Always check your answers. Again, is checking required?
Is checking
No.
required?
So checking, no, it's not required. So why do you check? Why do you check? Well, let me just tell you this. So you just know. So why do you check? Why do you check? Why do you check? Why must you check? Why must you check? Why? Should I tell you why? Because what? Because you make what? Very simple. It's a very simple rule. And you make mistakes. Okay, is that clear? The reason why you have to check is because you make mistakes. If you never make mistakes, then you don't have to check. Again, in this class, the penalties on any problem, any kind of mistake, is very high. You are able to regret. For tiny mistake, I could take up 8 points. That's my style. Because the answer you gave me is junk. Doesn't make sense. And many of you, when you graph this, your answer really doesn't make any sense. Doesn't fit. Okay, so that's why even if you make a tiny mistake somewhere, the answer you give me is junk. So you have to check. Again, checking is not required. So when you have really no time, you run out of time, then you have no time to check. But remember, you make mistakes. I make mistakes too. Now, I probably check far more than you do. Generally, I check about 3 times. I can check very quickly, so I check about 3 times. I check this way, that way. I also do the graph and this way, that way, and then I do fast check in different ways so many times. I check it too. So I'm a math teacher. So don't you think you have to check too? When I check 3 times, I think you should have to check more than I do, right? You do make more mistakes, but I make mistakes too. So I have to check it too all the time. So you have to check. So anyway, do some kind of check, and preferably do a direct check. A direct check means check against the original problem directly. So when you solve an equation, plug the solution into the original problem directly. So direct check, not a procedural check. Okay? Procedural check, you're just going through the answer again, but direct check is always better. Okay, so I think so much on that. So I think, any questions on problem number 7?
I have one question on number 7. You said x squared minus 2mx plus parentheses minus 2m plus 3m parentheses equals 0. Then you said that d equals to 0. How did you get parentheses negative 2m m parentheses squared minus 4 parentheses minus 2m plus 3m parentheses equals 0?
Let's see, because if you look at that equation, okay, so if you look at, so let me say this equation right here, if you look at that equation, what is A and what is B and what is that C? So in this case, what A is equal to what? A is equal to 1, and B is equal to what? It's equal to minus 2m, and then C is equal to what? Is equal to minus 2m and then plus 3. If m is a parameter, we are treating this m like a number. So if you look at the coefficients of x4 and x and 1, then that's what we see. And then now, what is that we want? Since we want the one distinct real root, meaning a double root, we don't want 2 solutions. A quadratic equation always have 2 solutions, either 2 real, or 1 repeated real root, or double root, or 2 complex. But in this case, we want 1. We want 1 real. So that means we want the discriminant to be 0. Discriminant, so we want what? To have 1 repeated real root, 1 double root, a double root or real root, a repeated root or double root. To have 1 double root, what? D is equal to 0. So what is D? D is equal to that B squared minus 4AC. And we want that 1 equal to 0. So basically, this is what we want. Want this. Need this? Yeah, we need meaning 1. So we want, so instead of say using different one, let me say 1 equals 0. And so 1, B squared is equal to B squared minus 4AC equals to 0. So what is the A, B, C in our case? A is 1, B is negative 2m, and C is equal to minus 2m plus 3. And that's what this is right here. And by the way, I did multiply that equation by 2 to get rid of the fractions. Okay? But you can apply this discriminant on this fractional with fractions as well. But you have to set one side equal to 0. The assumption is that the equation is in the form ax squared, and then bx, and then plus c equals 0. That's what the ABCs are. And then when you plug that in, either this form, and then you have to make one side equal to 0. So either you can leave the half x for half there, but whether you leave it or not doesn't matter. And then, of course, if you anyway, ABC, either ABC from this equation, but after we get one side equal to 0, the right side equal to 0, you get that, and then now b squared minus 4ac must equal 0. So what's b squared? B squared right here. B squared minus 4ac. A is 1, so there's not much, and then c equals c, and then that must be 0, and that's what we want in order to get one repeated real root. And then when you simplify that and solve that equation, you get this. Again, what is the best way to check? This case, this one, I think the best way is by graphing. Now, if you don't have graphing, a graphing tab next to you, then of course you can just You can just do this. You can check this directly. You can plug in one of the equations here. I think if you check one, the chances are the other one's probably right too. A good chance, but if you have time, then you should check both. So check this guy, plug it in, and then the equation that you'll be able to find one intersection. For the equation, you'll have one double. Okay, that's it. Grotto?
Thank you.
Is Grotto? Okay. Fish? Okay, fish. Okay. All right. Wait, how much? It's already 9 o'clock. Did we already waste this much time? We have to now get into limits today, right? Okay, so, all right, then, okay, should I save this page? Okay, I'll save this page. I'll take a screenshot and then clear. Okay, any questions on number 7? Again, there are many ways of doing this. Your solution might be a little bit different. And by the way, you know what? I wrote this equation right here using these steps here. But some of you were actually smarter than what you see right here. You did write y and then y, and then plus 3 over 2. And then you did write y plus 3 over 2. And then this is equal to m times x plus 1. This is actually the line equation, which passes through the point -1 comma -3 over 2, and with slope m. So if you got this line from the very first step, without this m and n stuff here, then that's great. In fact, that is correct. That will be even shorter method. And some of you, that's what you did. You got this line equation right here. In fact, this is the line equation, slope point form. Slope is m, which that's good. We don't know the slope, but we do have a point, -1 comma -3 over 2, and you get this line right here. And then once you get that line, and then of course once you come here, that is exactly the same line equation right there. Same line, yes, right here. So that's y equals mx and the plus n minus 3 over 2. So when you simplify this, that's exactly what you get. All right, and that's fine. Again, some of your solutions a little bit different, and that's okay. So don't worry if your solution is a little bit different from my solution. That's fine. Okay, is that clear? Small differences can show up anywhere, so I cannot explain all those small differences. So again, if your solution is a little bit different, then you know what? Then that's okay. If your solution is very different, then I always recommend you to study the solution which I present you on the solution or present you in class. Okay? Because the method I present you is usually the most standard way, the most efficient way, the shortest way, the best way. Usually that's what I give you. Sometimes I will do a problem in a way which is not the best way. And in those cases, I will tell you that that's not the best way. All right? I usually tell you that. But your job is to learn the problem in many different ways. That is the way you can learn the best way. And again, on the test, you don't need to show me two ways. You just show me one way. You show me one way. And again, I only deduct points if it's a mistake, not when your method is ugly. Okay, I don't deduct points because the solution is ugly, but when you make a mistake. But if you choose the wrong method, now it's more messy. There's a high chance of making a mistake. Now, once you make a tiny mistake, what happens? Minus 2,000 points. There you go. If you make a tiny mistake, how many points off? If you make one tiny mistake, how many points off in this class? 5,000 points off. Is that clear? Remember, make a tiny mistake, that will be minus 10,000 points off. Okay? Minus 10,000 points. So I'm very harsh on this. So your method be easy. You better know the way. If you choose the wrong way, it's too risky. You make a mistake. And then the entire form will blow up. Okay, so I think that's good. And so let me just save this and then clear this. And so now, it is now time for me to move on. So let's now move on. Section 1.1. Okay, we finished 1.1. So what I'll do is I move to skim through section 1.2. 1.2. Okay, let me just skim through this 1.2 and 1. Okay, so 7.12 1.1. We did 1.1. 1.2 is this is 1.2a. Polypower. Polypower means polynomial functions and power functions. The two important functions you need to know in this class, or these are the two kinds of functions which are very general, very basic kinds of functions. One is polynomial functions, and then the second one is power functions. Very basic functions. Again, there are zillions of functions out there. There are many different kinds. The easiest kind or the most studied functions in math, throughout math, not just for algebra, but not for calculus 1, but for any math class, no matter how high you go in math, polynomials will show up all the time. That's there. Polynomials are very basic, but they are the easiest kind of functions to deal with. So they are the most common functions out there.